Okay, hi everyone, welcome back to this video series on data centers. Internetworking Basics. It's likely at some point user response will dwindle to a slow crawl as your network grows and grows. And with all that growth, your LAN's traffic congestion will reach epic proportions. The answer is to break up a really big network into smaller ones, something called network segmentation. You can do this by using devices like routers, switches and bridges. Figure 2.1 displays a network that's been segmented with a switch so that each network segment connected to the switch is now a separate collision domain, but make note of the fact that this network is still one broadcast domain. Keep in mind that the hub used in figure 2.1 just extended the one collision domain from the switchboard. Here's a list of some of the things that commonly cause LAN traffic congestion: too many hosts in a broadcast or collision domain, broadcast storms, too much multicast traffic, low bandwidth, adding hubs for connectivity to the network. Take another look at figure 2.1. Hubs don't segment a network, they just connect network segments. So basically it's an inexpensive way to connect a couple of PCs together, which is great for home use and troubleshooting, but that's about it. Now, routers can be used to connect networks and route packets of data from one network to another. Cisco became the de facto standard for routers because of its high quality router products, great selection and fantastic service. Routers by default break up broadcast domain, the set of all devices on a network segment that hear all the broadcasts sent on that segment. Figure 2.2 shows a router in our little network that creates inter-network and breaks up broadcast domains. The network in figure 2.2 is a pretty cool network. Each host is connected to its own collision domain and the router is created to broadcast domain. And don't forget that the router provides connections to WAN services as well. The router uses something called a serial interface for WAN connections, specifically a V.35 physical interface on a Cisco router. So let's just go back here to figure 2.1. You can see here's a hub. It doesn't help with segmentation, it just adds, again as it says, another broadcast domain. Breaking up a broadcast domain is important because when a host or server sends a network broadcast, every device on the network must read and process that broadcast unless you've got a router. When the router's interface receives this broadcast, it can respond by basically saying thanks but no thanks and discard the broadcast without forwarding it onto other networks. Even though routers are known for breaking up broadcast domains by default, it's important to remember that they break up collision domains as well. There are two advantages of using routers in your network. They don't forward packets by default. They can filter the network based on layer 3 network layer information IP address. 4 router functions in your network can be listed as follows: packet switching, packet filtering, inter-network communication and path selection. Unlike layer 2 switches which forward or filter names, routers or layer 3 switches use logical addressing and provide what is called packet switching. Routers can also provide packet filtering by using access lists, and when routers connect 2 or more networks together and use logical addressing IP or IP version 6, this is called an internetwork. Last, routers use a routing table map of the internetwork to make path selections and to forward packets to remote networks. Conversely, switches aren't used to create internetworks. They do not break up broadcast domains by default. They are employed to add functionality to a network LAN. The main purpose of a switch is to make a LAN work better to optimize its performance, providing more bandwidth for the LAN's users, and switches don't forward packets to other networks as routers do. Instead, they only switch frames from one port to another within the switched network. Switches break up collisions domains. That is an Ethernet term used to describe a network scenario wherein one particular device sends a packet on a network segment, forcing every other device on that same segment to pay attention to it. If at the same time a different device tries to transmit, leading to a collision, both devices must retransmit one at a time, not very efficient. This situation is typically found in a hub environment where each host segment connects to a hub that represents only one collision domain and only one broadcast domain. By contrast, each and every port on a switch represents its own collision domain. Figure 2.3 shows how a network would look with all these Internetwork devices in place. Remember that the router will not only break up broadcast domains for every LAN interface, it'll break up collision domains as well. When you looked at figure 2.3, did you notice that the router is found at the center stage and that it connects each physical network together? We have to use this layout because of the older technologies involved, bridges and hubs. On the top Internetwork figure 2.3, you'll notice that a bridge was used to connect hubs to a router. The bridge breaks up collision domains, but all the hosts connect to both hubs are still crammed into the same broadcast domain. Also, the bridge only created two collision domains, so each device connected to a hub is in the same collision domain as every other device connected to that same hub. This is actually pretty lame, but it's still better than having one collision domain for all hosts. Notice something else. The three hubs at the bottom are also connected to the router, creating one collision domain and one broadcast domain. This makes the bridge network look much better. So here you can see, here's our bridge, switch, router, and possibly another switch. The best network connected to the router is the LAN switch network on the left. Why? Because each port on that switch breaks up collision domains, but it's not all good. All devices are still in the same broadcast domain. Do you remember why this can be a really bad thing? Because all devices must listen to all broadcast transmissions. That's why. And if your broadcast domains are too large, the users have less bandwidth and are required to process more broadcasts. The network response will be slow to a level that could cause office riots. Once we have only switches in our network, things change a lot. Figure 2.4 shows a network that is typically found today. So here's our router and 4 switches and 2 machines hanging off each switch. Here I've placed the LAN switches at the center of the network world, so the router is connecting only logical networks together. If I implemented this kind of setup, I've created virtual LANs, VLANs. It's really important to understand that even though you have a switched network, you still need a router or layer 3 switch to provide your inter-VLAN communications or inter-networking. Don't forget that. Obviously, the best network is one that's correctly configured to meet the business requirements of a company it serves. LAN switches with routers correctly placed in the network are the best network design. Internetworking models. When networks first came into being, computers could typically communicate only with computers from the same manufacturer. For example, companies ran a complete DECnet solution or an IBM solution, not both together. In the late 1970s, Open Systems Interconnection OSI reference model was created by the International Organization for Standardization to break this barrier. The OSI model was meant to help vendors create interoperable network devices and software in the form of protocols so that different vendor networks could work with each other. Like world peace, it'll probably never happen completely, but it's still a great goal. The OSI model is a primary architectural model for networks. It describes how data and network information are communicated from an application on one computer through the network media to an application on another computer. The OSI reference model breaks this approach into layers. In the following section, I'm going to explain the layered approach and how we can use this approach to help us troubleshoot our networks. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.